Let's take a look at rational inequalities, like this one. So we've got this rational function less than or equal to 0. So in other words, we want to know what values for x. We want to find regions from which we can take x values, plug them into this function, and get negative numbers. Or another way to look at it, we want to find where the graph of this function is below the axis or on the axis. See, less than or equal to. That's what we want to find. So now, if you look at the graph of this function right here, you see the vertical asymptotes, you see the x-intercept, and notice that's where the changes take place. Notice the graph is below the axis up to this x-intercept, and then it crosses over and it's above the axis. So we have part of the solution region over here, but right here at the x-intercept, it changes, and now it's above. Also notice changes occur at the vertical asymptotes. So notice the graph is above the axis here. You come up, you step across this vertical asymptote, and that's where you go down, and now you're below the axis. Likewise, you're below the axis, you come to the vertical asymptote, step across, and now you're above the axis. So things happen at the intercepts and at the asymptote, at the x-intercepts and at the asymptotes. So here's what we need to do. We need to first of all find the x-intercept. So I take the numerator, set it equal to 0, and solve it. And I get -3 here. I also want to find the asymptotes. So I take the x squared minus 1, set that equal to 0, and find that x equals plus or minus 1. Now we use these numbers, -3 and plus or minus 1, to divide the number line. So we've got -1 here, 1 here, and -3 over here. So, and I realize this probably isn't to scale, but anyway. So now what we do is we pick representative numbers from each region. Okay, so I'm going to pick a number representative of the region less than -3. So there we have -4. I'm going to pick a number between -3 and -1. -2 would be a good one. A number between -1 and 1, 0, and a number bigger than 1. Now these are the values that we're going to test. So I'll make a little table. I have the x values and I have the function. And what I'm going to do is I'm just going to plug each x value in. So I've got this test value over here, -4. I plug it in and I get -4 plus 3 over -4 squared minus 1. Well, this top is negative. The bottom is positive. So that means that I get a negative. I get something less than 0. So that's part of my solution region. Now I next plug in -2 to test this region. Test this region in here. Or actually this region, I'm sorry, this region right here, between -3 and -1. So I plug that in. See, -2 plus 3 divided by -2 squared minus 1. This top is positive, the bottom is positive, so that's greater than 0, and that's not what we want. We want something less than or equal to 0. Then I test this region, between the asymptotes. I plug in the 0, and I get this. I get 3 over -1. See, if I put a 0 in for the x, that's what I get. That's definitely negative, so that's part of my solution region. So my solution region is over here and here. Now, finally, I'm going to test the 2. And we can see from the graph that's above the axis, but let's go ahead and test it. 2 plus 3 over 4 minus 1, well, that's definitely positive. So here's my solution. Notice 3 is right, -3 is right here. So I'm going to have -infinity to -3. So notice over here, this region between -1 and 1, notice I don't have a bracket here. I have the parentheses indicating that -1 and 1 are not included as part of my solution region. And you might wonder, well, why is that? You've got a less than or equal to here. Well, the reason is because At -1 and 1, that makes this function undefined. Those are the asymptotes. We never include the asymptotes. If this were less than or equal to, we don't include the asymptotes. So the -3 is included because it's less than or equal to. So I have to account for where it's actually equal to 0. However, with these asymptotes, I'm not going to include those. Okay, so that's my solution region there.